Been talking about limits, but now's the time to define them rigorously and mathematically. Now here's the definition, and before we go through it, I want to explain a couple things. This symbol right here is epsilon, and this symbol right here is delta. And we're going to use these to mean very small, all right? Let's look at the graph. Again, I'm not jumping into the definition yet. If I say the limit as x approaches a value c, so this is my value c right here, all right? Now c is always an x value because x is approaching c. So the limit as x approaches c of my function is equal to, and I'm going to switch colors here, it's equal to L, all right? This L is always a y value on your graphs. Now, if I were to scooch up just a little bit, if I were to add epsilon to L and define this region right here as L plus epsilon, and then scooch down and subtract epsilon. So I have this L minus epsilon. So I've got this region right here that I'm working with. The definition says it doesn't matter what epsilon I pick. I pick any epsilon I want. All right? And no matter what that value is, I can find a delta, all right, so that the function x minus c is less than delta. So basically I've got c plus delta to c minus delta here. So this is the region here. So I pick epsilon, I can find, or rather there exists, because you can't always find it. That's kind of the hard part sometimes. There exists a delta so that if I am within delta of c, then f minus L is less than epsilon, or the functional value I find will be within this L plus epsilon range, or L minus epsilon range. So it doesn't matter what epsilon I pick, I can find a delta. So now let's come up and read this. A function f, let f be a function defined on an open interval containing c, except possibly it's c itself. Now this, you remember, the function does not even have to exist at the point. So that takes care of that. And L is a real number. The statement the limit as x approaches c of f of x equals L means for every epsilon greater than 0. So for every epsilon you can find, and we put that in red, so for every epsilon you can find, there exists a delta, such that if x minus c, the absolute value of x minus c is less than delta, so x is arbitrarily close to c, then the absolute value of the function minus the limit is less than epsilon. Let's try one. Use the epsilon delta definition of a limit to prove that the limit as x approaches 2 of 3x minus 2 is equal to 4. Well, the first thing we have to do is kind of identify what some of this stuff is. Let's see what colors we're using. This is L. All right, so over here I'm going to put here L is 4. F of x, this is f of x. So f of x is 3x minus 2. Let's see, what was my, I think, C here is 2. Now, what I want to do is write out the definition as I say it. All right. For every epsilon greater than 0, there exists a delta greater than 0 such that, and I'm not going to write all of that out. 0 less than x minus c. And remember, x minus c has to be less than delta. If and only if 0 is less than the absolute value of f of x minus L is less than epsilon. Now, let's look at this. Let me start with this part right here. All right. So 0 has got to be less than the absolute value. Now, what's f of x? I'm going to do this in colors for you. 3x minus 2 minus L. So it's minus L. Oh, excuse me, L is 4. Let me undo that. Less than epsilon. All right. So let me play with this a little bit. This is 3x minus 2 minus 4 is 3x minus 6. Now, let me factor 3 out. 0 is less than 3x minus 2 is less than epsilon. Now, I'm going to divide all 3 parts of this by 3. So 0 is less than absolute value of x minus 2 is less than epsilon over 3. All right, now I have gotten this. This comes from 0 is less than the absolute value of f of x minus L is less than epsilon. So I can pick delta. All right, if I pick epsilon here, and it doesn't matter what I pick, I can see that 0, I'm looking at this part right here. See, I've gotten this in the form of x minus c. I didn't mean to, actually I did. It's what I was shooting for, but it kind of snuck up on me. So this is less than delta. So if the absolute value of x minus 2 is less than delta, then x minus 2 has got to be less than epsilon minus 3. So what we're asking is, what is delta? What does delta have to be? And it's very easy to see when I've done this right here, that if I let delta equal epsilon over 3, then for every epsilon I pick, there exists this delta such that the absolute value of 0 minus x, 0 is less than x minus c is less than delta, means that the absolute value of f of x minus L is going to be less than epsilon.